Hello, and today we're going to be talking about locuses. So what is a locus and how do we define it and how do we actually do some things with it? So a locus is just a path traced by a set of conditions. So here on the screen here I have a condition. So the locus of point P, the coordinates are x and y, given that P is equidistant from A 2, 0 and B 0, 2. So this word here, equidistant, that's just saying that the distance from A to P and the distance from B to P are the same. It's an equal distance. That's all that's saying there. So we write this out as PA is equal to PB. That's great, but how do we actually manipulate this? How do we actually derive some sort of equation that satisfies this condition? So this is where the distance formula comes in. So I'm going to get rid of this for now. So let's think about 2 points, and I want this distance here. So I can think of Pythagoras and try and solve for C. We have A and B like this. So now we just need to work out what A is and B, and then we can solve for C. So A, if this is x1 and over here is x2, then this distance will be x2 minus x1, right? So that's equal to A. So similarly B, this is going to be y1 and this is going to be y2. So B is equal to y2 minus y1. It's the difference of those two things. And you can sort of see where this is heading. This is sort of similar to our gradient, but really we're looking for distance, not gradient. So now we just need to realize that c squared is equal to a squared plus b squared. So c, which is our distance, will be a squared plus b squared, square rooted. So now let's sub in all of the stuff. So the distance from any 2 points A, B is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, all square rooted. So with this distance equation we can actually do some things in relation to finding something that satisfies the conditions that we have above here. So remembering at the start that I said from distance from P to A has to be equal to distance P to B. So now we can actually use the distance formula to actually find these distances here. So let's make some space. So I'll write it again. PA is equal to PB. So now let's write the distance formula. So from point A, we're going to have P is our first thing, and we said that P is just x comma y. So let's sub in x minus, and then we said A was 2 comma 0. So we'll put 2 there. Square it, and we'll add. And now we'll say our y, and we'll subtract 0, and then we'll square, and then we'll square root. And there's our first distance equation. But this also has to be equal to another distance equation with slightly different values. So from P to B, where we said B was 0, 2, this would be minus 0 squared plus and y minus 2 squared. Now we actually want to somehow manipulate this to get something that we are a little bit more familiar with. So let's square both sides so we get rid of the square root. So we now have x minus 2 squared plus, and then we can write just y squared is equal to x squared plus y minus 2 squared. And now we can expand these brackets. So we get x squared minus 4x plus 4, remembering that the a plus b squared is equal to a squared plus 2ab plus b squared. And then we'll add the y squared at the end. And this is equal to x squared plus y squared minus 4y plus 4. Now we can see that there's quite a bit of cancelling actually happening here. We can get rid of the y squareds, we can get rid of the x squares, we can get rid of the 4, and now we're just left with minus 4x is equal to minus 4y. And then we can divide both sides by minus 4, so we get x equals y, and hold on, that's a linear equation. So what we've said, essentially, if we actually graph this, here's a and b. A is here, b is here. What we've said is if we draw a line straight through the origin here, if we draw a line to this new equation from both sides, we're saying that these are equal. There's also a special point on this called the perpendicular bisector, and what that means is that the angle that these two lines create in contact to this line from A and B are right angles. That's a perpendicular bisector. It's the shortest distance that you can have from B to P and A to P. So you're not always going to have nice cancelling like we have here, where everything pretty much cancelled each other out and we got the answer fairly quickly. So let's do another one. So again, I want PA to equal PB, but I'm going to change my coordinates. So A is now 1, 5, and I'm going to make B 4, 2. So let's do the same process again. And again, we'll say P of X and Y. So let's start with for PA. So we'll have X and minus A is the distance squared plus the Y, which is 5, Y minus 5 squared, square rooted, is equal to the square root of X minus 4 squared plus Y minus 2. Now this is going to be a little bit more messy, but it's important to understand how to treat this. So let's square both sides again, so we get x minus 1 squared plus y minus 5 squared equals x minus 4 squared plus y minus 2 squared. Let's expand the brackets. We have x squared minus 2x plus 1 plus y squared minus 10y plus 25 equals x squared minus 8x plus 16 plus y squared minus 4y plus 4. So now this is very messy, but we can again cancel down a couple of things. So this y squared, these x squareds, and that's all we can do at the moment. But we can collect like terms, and we can, so let's collect like terms. So we get minus 2x minus 10y plus 26 is equal to minus 8x minus 4y plus 20. So now we can, how you actually get your result really depends on what the question is asking for, because there's technically 3 different answers for this one question. So let's show one way. We'll subtract 20 over here, so we get 6, and then we'll add all of these across. So we plus 2, there's minus 6x, and then we'll plus minus 10y, and we get plus 6y. You can factor out the 6, so we get 6 equals minus 6x plus 6y. We can factor out the 6, so we can just divide by 6 on both sides, and that will give us the same equation. So we'll get 1 equals minus x plus y. We can also flip this around. Minus y plus x equals minus 1. We can also get rid of the x on the other side, and we can say y is equal to x plus 1. We can also try and get this equation here and let it equal to 0, so we get y minus x minus 1 equals 0. So there's a lot of different answers that you can come up with for this one set of conditions. You really have to look at the question, see what actually makes more sense, what's more useful in this case, and give your answer accordingly. So that's all the time that I have for locuses. If you have any questions, feel free to leave a comment down below or contact me on social media, and I will see you in the next video.